Hello and welcome. Today we're going to be having some fun with Microsoft Azure and Unity. More specifically, we will be using Azure Custom Vision to train a machine learning model with images of utility poles from a Unity simulated world. This video is meant to showcase Azure Custom Vision by closely simulating a real-world drone use case. Here is a high-level design of what we will be doing. The drone will move to each utility pole and snap pictures from the specified markers on the game object. Most have 3. These images will be uploaded to an Azure storage account as image blobs using the Azure Storage REST API. Once we have collected our images, we will begin labeling with Azure Custom Vision and train our model. This model will then be exported as Onyx for integration into the drone behavior tree for real-time inferencing. Before we continue with the drone, let's go ahead and get things set up on Azure. We will first want to create a resource group for the project. To do this, select Create a New Resource, then search for Resource Group. Name the resource group and select the region closest to your geographic location. Now let's create a storage account. From within the newly created resource group, select Create at the top of the screen. Then select Create under Storage Account. Select the resource group that was just created and give it a meaningful name that meets the naming rules. Here you can see my first name was too long and I had to shorten it. Once you're done, click on Create. With our storage account created, we're going to now want to create a container to store our drone captured images. Next, let's create our Custom Vision service in our resource group. Search for Custom Vision when creating a new resource. We will create the service for both training and predictions. Again, give the service a meaningful name in your region. I am using the standard pricing tier as I may go beyond the free tier's limitations in some upcoming experimentations. With the cloud services all set up, it's time to send off our drone to collect some images for training our model. With our images collected for training, we can now go to the Custom Vision portal at customvision.ai to train our model. Once at the portal, create a new project for object detection. In order to export the model as Onyx, we will have to choose the General Compact under Domain and then choose Basic Platform under Export Capabilities. Once the project is created, we can add the images captured by the drone from our Unity simulator. After all of our images have been added, we can go ahead and start labeling by selecting the regions that we want to tag. Alright, now with labeling complete, we can go ahead and train our model using the Azure Custom Vision portal. I have chosen advanced training to improve the performance of our model. However, I am going to limit it to just 1 hour of training time. With training complete, we can export our model by going to the top and choosing Export. And for integration to our Unity project, we can export in the Onyx format by selecting Onyx. And it will take a few moments for it to prep our file, and then we can download. Once downloaded, I am bringing the model into Unity, and here I'm attaching it to our drone. And once attached, I am changing the drone from training to inferencing. We are now ready to have some fun and let the drone run through the map with the model. One slight issue I ran into was converting the model prediction bounding boxes into a Unity rect transform for the screen overlay. However, this was overcome once I realized I had to use the rect transform anchor position and not the local position. Another slightly obvious issue is how the drone is set up for training and inferencing. It is currently running through the same data points with the slightest variations. In order to increase the robustness of the model, logic could be added to shift the order of the utility poles, modify the directional light intensity, and offset waypoint locations. For the most part, I am satisfied with this experiment and ever more curious in applications of Unity HDRP for simulated training data. Please like and subscribe if you found this content interesting. Thank you and have a wonderful day.